Question number 3.258. Two long, thin parallel conductors of the shape as shown in figure. One is very thin, another is just like a parallel plate or sheet of the conductor. Okay. One is carrying current I1, second one having current I2. The separation between the conductors is A and the dimension of second conductor is B. Okay. So we have to find out the magnetic interaction force between them. Okay. And per unit length. Right. So if we want to find out magnetic force, so let's assume a very thin shape of wire here. Okay. So for that we need to cut a very small segment. Let's assume its width is dx and it is at distance x from first conductor. Right. So along the width B, current I2 is passing through conductor number 2. Okay. So if we find out current passing through this dx segment, then we can write it as I2 over B, that is per unit width, multiplied by dx. Number 1. Number 2, we can find out the magnetic field at this point due to this current carrying conductor I1, which is at distance x. So magnetic field B1 at distance x is equals to mu naught I over 2 pi x. Okay, and we already know that if there is a current carrying conductor having length L placed in magnetic field B, like there is a magnetic field B and a current carrying conductor of length L is placed, then force experienced by this conductor is I dl cross B. Although here the direction of magnetic field, if we'll use right hand thumb rule, is downward and it is perpendicular to length of the conductor, so we can write it as I dl into B. Okay. So the force experienced by the second conductor is current passing through second conductor, okay, that is dI2 into magnetic field due to first conductor B1 into length of the conductor dl. But here we are keen to find out force per unit length, so we can take it as dF over dl is equals to dI2, that is I2 into B into dx into the magnetic field, that is mu naught I1 over 2 pi x. Right. So from here now we can integrate this expression. Okay. So if we'll try to find out total force. So let's just simplify this term, that force per unit length is equals to, constant terms is mu naught I1 I2, right, divided by 2 pi B and integration dx over x. Now this x is changing from B to A plus B, from A to A plus B, right. This coordinate is A and second coordinate is A plus B. So it is varying from A to A plus B. Now integration of this is dx over x is ln x. So from here we'll get expression for the force per unit length over this conductor is mu naught, this is force of interaction and it would remain same for both the conductors, over 2 pi b ln A plus B over A. So this is magnetic force of interaction between two conductors.